Can you confirm if my screen is visible?
Yes, sir.
Okay.
Yes, sir.
Okay. Thank you for confirming. So today's topic is you're from Unit 4. It's a logistic regression, and I think this is one of the classification algorithm, and you people might be aware of this classification algorithm. So we typically done one regression that was simple linear and multiple linear regression, that is for predicting continuous output. Okay. And this logistic regression is for predicting that discrete output, the binary output. Okay. So logistic regression is a classification algorithm, but the simple linear regression is just a regression that is used for predicting continuous output. So don't get confused. Okay. So we'll try to cover some of the important topics which are typically covered in this logistic regression. For example, it's very important to understand the decision boundary, right? So this decision boundary is a bit, this is a crux of, you can say, the logistic regression. And this logic function, I'll tell you what is that, and this confusion matrix. So confusion matrix, decision boundary, and this logic function is very much important, and we will see using one of the data set how you can implement through Python. Okay. So before going to explain what is logistic regression, you might have seen this sustainable development goal of UN, right? So there are 17 SDG, that is sustainable development goals. So how you can connect artificial intelligence with SDG, right? For example, if you are developing any healthcare systems, so you are addressing this SDG number 3, good health and well-being, right? If you are doing something related with the smart cities, so you are addressing the SDG number 11. Similarly, if you are doing something related with agriculture, right? So you might be addressing this SDG number 1, SDG number 2, or maybe SDG number 15, the life on land, right? So there are many SDGs, and just think of, because you are from the business background, you people. So, I mean, you must understand how this SDG and how you can connect SDG with AI, okay? So, sustainable development goal and AI will give you a crux and will give you an idea, the innovation idea, so that you can develop product related with AI, you can develop AI systems, or maybe a software, or maybe the hardware, right? You can develop AI systems. So that is why I'm just giving you this clue, and then I will connect with SDG, right? So just see. When you are working on any logistic regression, the first case, just understand, I'm just giving you a first case, the business problem, right? For example, a doctor wants to predict the likelihood of successful treatment of a new patient, right? Based on various attributes of a patient, such as blood pressure, hemoglobin, blood sugar level, name of the drug given. These are the attributes, okay? And here the target variable would be the past cure status, and the predicted class would be contain the value yes and no. So whether the based on the historical data of a patient, of a new patient comes in, and through AI systems which we have developed, if you put in the data, whether that patient will be cured or not, that is your business problem, right? And this business problem is related with your one of the SDG which I have shown you in the 17 SDG, right? And the business benefit, what you are going to get, the business benefit obviously would be the what kind of drugs you are giving. And also doctor can predict the probability of a cure and identify the necessary changes through the treatment and drug recommendations. So these would be the business benefits. And also if you are running any, let's say, hospitals, okay, and if you are designing any AI system, so you will look for the business benefits as well, right? Because once you are curing a patient, so obviously you will provide the drugs, you will provide so many things that is necessary to make sure your patient gets cured, right? So just relate with these things, because it's not only you have to develop the the AI systems or any algorithms, you also look for the business benefits. Okay. Similarly, the second case, if you see the second case, this is related with the loans, banking loans. So you might have seen there are many cases where people get the fraudulent kind of stuff. They do, they take money and they go away with. Okay, so a bank loan officer wants to predict if a loan applicants will be a bank defaulter or not. So this defaulter and not defaulter, just see the two things. Defaulter and non-defaulter is a binary. There are two peoples, there are two category of the people. So by looking at the data, by looking at this caselet, you can say you will have an idea that you have to work on a classification problem, because there is a defaulter and non-defaulter. It's a binary problem. Okay. And if a loan applicants will be a bank defaulter or not, based on attributes such as, obviously you will have certain attributes: loan amount, monthly installment, what they are paying, and their tenure, and how many times the applicant has been delinquent, and their income, debt to income ratio, etc. So you will have, obviously a typical bank have, let's say, 10 to 15 features, and based on that they decide whether the customer is gonna default or not. They do have a historical data, but if a new customer comes in, right, whether they're gonna default or not, that will be a predictive analytics. And how you're gonna apply? You're gonna apply through logistic regression. This is one of the simple algorithm for a classification problem. Okay, so what business benefit you're gonna get? So once classes are assigned, classes means default and not default. There are two classes. So in a, obviously in a classification problem, the class labels, here the class label is defaulter and non-defaulter. Okay, the bank will have a loan applicants data set with each applicant labeled as likely or not likely to default. Based on these labels, the bank can easily make a decisions on whether to give a loan to applicant, the credit limit and the interest rate each applicant is eligible for based on the amount of the risk involved. So you might have seen people calling you for the credit cards. Obviously they have your financial transactions with them, and they see who are the potential customers, right? They can at least get this credit card, or they can offer you the loans based on your historical and, you can say, the transactions. So they do have that, and they apply this logistic regression, and they just fill out, and you can say they bring out the customers who are the potential customers for taking loans or for credit cards. So how they manage it, they model it using this AI, right? This AI algorithms, they apply many algorithms, but the basic one is your logistic regression. So just understand the business problem and also the business benefit, because whenever you're designing any AI systems, you have to take care of these two things, because you cannot only create AI systems that don't give you a business benefit. Okay, it must give you some business benefit, or it must be used for people's welfare, right? It's sometimes it's called AI for good. You might have heard this statement somewhere, AI for good, right? So before that, you'll see this one. This is just a schematic diagram. This visuals will make you clear that how classification algorithms, obviously it's logistic regressions. For example, user age, user income, and user gender. That is the three features: age, income, and gender. And we are deciding whether the people is gonna purchase or not, right? This purchasing power, right? We are deciding whether people are going to purchase or not, yes or no. So the purchasing intention is being decided by age, income, and gender. There are three features. So we will apply this logistic regression. This is a binary classification, yes and no. Okay. So so this is a binary classification. Okay. So this is a feature and this is a target. Sometimes it is called a label or class. Okay, so don't get confused. And also I'll try to cover this I just want that you do not get confused with this regression. Okay, the simple linear. So in the regression you have a dependent and independent variable, and we have some data points once you plot, right? I'm just going through because I have already taught you, but let me just remind you that how this regression and the logistic regression is different. Simple linear and the logistic regression is different, how they are different. Okay, so in regression, simple linear regression, you have a dependent variable, you have some intercepts, and the coefficient, you can say this slope parameter, the coefficient of independent variable, if you have many, then x1, x2, x3 and their coefficients, and this residual, you can say this residue. Okay, so intercept is typically called a bias term. So every single machine learning algorithm will have a bias term. So you might have heard of something called AI biasness. Okay, so every single AI system, so when you develop, they give you some kind of a biasness. Okay, so even we people are biased, right? So how we mitigate the bias? Similarly, every single AI systems or AI algorithm will have some biasness in terms of errors. So in regression, when you see the error terms, that is a biasness. So how biased your model is while predicting. So whenever you are judging a people, how biased you are, right? So it's a similar way, right? Similarly, this just a maths, how to calculate this least square methods and how you minimize the error, right? So in simple linear regression or multiple linear regression, the constant task of this ML model is to minimize the error. So then only you can maximize the R square value, right? That is why they keep on minimizing the error. And this is just the visuals, how if it is a regression case, then how you are going to predict it. For example, the size of the house is one of the independent variable, and we are estimating the price, right? So price is being determined by this size of the house. Okay, so this is a simple linear regression case because we have one independent variable. Okay, so these are some visuals, and just this one is supervised learning. You all know how if data is supervised, means your output and input has there's some they have some input and output in the data set. So here there are three outputs. So this is not a binary classification, this is a multi classification, you can say. So in multi classification, typically logistic regression is avoided. Okay, so if you have a multi classification, you go with the decision tree, random forest. Okay, but majority of the time logistic regression is applied for binary classification. Also you can model it for more than one class, but majority of the time you will see in the research paper it's for a binary classification. Okay, similarly, this is one of the visuals for binary classification. Your data is labeled data. Whenever you see the labeled data, it means your data is supervised, because this red fruits is being labeled as an apple. So when you give this data to AI systems, AI system is gonna recognize this is apple because this is labeled, already labeled. You put a label on water bottle, let's say. If it is not labeled, you will get confused whether it has acid or water, right? So in that case, labeling of the data, because once you label the data, and how you can train AI systems. Okay, because if your data is not labeled, this will be considered as an unsupervised learning, because data is not supervised. There is no input output combination. That is why it is called unsupervised. Okay. Similarly, this visuals, I think I have shown you somewhere. Your data is labeled x1 and x2 and the label. Okay, this is input feature x1 and x2, and this label is your target variable. Sometimes it is called a class. So when you put x1, x2 as a 1 and 2, label is gonna get 1. So data is supervised, but this is unsupervised, you can say unlabeled, means this is unseen data. You don't know if you give 4.1 as a x1 and x2 as a 2, what this model is going to give you. So once you train your model up to this and you provide this unseen data, then only you will get some result, right? So that is why this is semi-supervised, because some of the rows are supervised and some of the rows are unsupervised. Okay. Similarly, on the right side, if you see, this is a cat, this is a dog, but here there is a no labeling. Okay. So if you put data to AI systems, let's say computer vision systems, once you have developed and your data is not labeled, means you don't have a training data set. If you provide the test data set, they don't gonna give you anything. Okay. This is unlabeled data. Your AI systems gonna recognize you, let's say dog as a cat or cat as a dog. Okay. So that is why majority of the time you will see the data scientist, there are you can say the data analyst for that matter, their work is to label the data. It's a part of data pre-processing, data cleaning, or something you can say before the building of ML systems. Okay. So the labeling of the data is important. Okay. Once your data is labeled, it's okay. But if the data is not labeled, then you have to go with the unsupervised learning, clustering. Okay. Maybe you can go with the principal component analysis, that is a PCA. Okay. So when you apply this classification problem, okay, for example, you are working on any project, right? Now let's say if it's a website company, let's say, or maybe some digital marketing company, right? Okay. And they just give you a project call whether the email they are getting every day is a spam or not, right? This could be the one of the use case. So now your manager has given you a task that what kind of algorithm you will go with. You have a data set, your data set is supervised. So how you gonna classify it? So it will come under the classification problem. Now you have a two class labels. One is a spam and other one is not a spam. Okay. So obviously you will go with the one of the algorithm. Obviously the basic one is logistic regression. Okay. Whether the online transaction is fraudulent or not, if it is a fintech company, they're gonna trace it out whether the transaction happening is fraudulent or not. Then they're gonna raise the red flag, right? Similarly, if a tumor or not, if there are some images available with you, and some rain's gonna happen or not tomorrow. So these all are the case of classification algorithm. Okay. So in classification algorithm, there will be binary. We are talking of the binary classification. Okay. So logistic regression typically is a predictive algorithm using independent variable to predict the dependent variable, just like linear regression. But the difference is that dependent variable should be categorical variable. This makes logistic regression and simple linear regression different. Your output must be categorical. Categorically you are seeing something, 0 or 1, yes or no, fraudulent or non-fraudulent, churn or not churn, right? So this is the the typical difference of logistic regression and the simple linear. And the independent variable can be numeric or categorical variables. If you see the logistic regression data set, you will see some of the features are numeric and some are categorical one. But the dependent variable always be categorical. Okay. And you apply this logit function. This is sometimes called a logit function to model the conditional probability, because y is 1, output is 1, keeping all the features. Similarly, output is 0. Obviously, here let's say you can just interpret it like customer 1 means churn and y0 means not churn. So customer is going to churn keeping these variables x1, x2, x3. Okay. Similarly, customer is not gonna churn keeping these variables. So this is a conditional probability. Okay. So we will see how this probability is you can model it while developing this logistic regression. Just see. So in logistic regression, if you see, they use sigmoid function. This is called a sigmoid function to deal with the outliers. Okay, so logistic function is a sigmoid function which takes any real value between 0 and 1 and can be written as below. So this is called a sigmoid function. This is typically looks like a S curve. Okay, so in next slide you will understand what is significance of this sigmoid function, why we are not using other functions. We do have some linear functions, maybe sine function, cosine functions. Why we are using this sigmoid function and making this is a flat, and why this is between 0 and 1. If you see, this is a 0 line and this is 1 line. Why it is oscillating between 0 and 1? Okay, so this we will try to find it out in case of logistic regression. Okay, so let's say we have a case called y equal to mx plus c. So we have to compare it with simple linear or multiple linear regression. Okay, so this z is equal to y equal to mx plus c. Okay, and when you put in the function fz, okay, 1 divided by 1 plus e to the power minus z, and we have to put mx plus b here. Okay, so this is y. Now our equation looks like this. Okay, this is a sigmoid function. Okay, so this slide is important in a, let's say, linear regression to the classification problem. Okay, we have to see this one, y equal to b0 plus b1 x1 plus bn x1. So this y is your output, let's say churn or not churn is y will take a value of 0 and 1. b0 is your intercept, this is a bias term. b1 x1, this is x1 is one feature and their coefficients. Okay, similarly to, let's say if you have a 10 independent variables, so you will have a 10 b1 b2 to b10. Okay, so this looks like a simple multiple linear regression, but we have to model it like logistic regression. Okay, so when you put this y into f of y, this equation looks like this, the value will looks like this. When you put y equal to, let's say 0 1 2 3 4 5, the value of fy here, obviously the value of fy will always come under 0 and 1. It will not go beyond 1 and beyond 0, this one. Okay, it will be between 0 and 1. Okay, so if the value of p, okay, greater than 0.5, then it will be a class 1, let's say churn. If the value is less than 0.5, then class would be 0, that is a not churn. Okay, that is why the classification happens. For that you require this sigmoid functions, because when you apply these sigmoid functions, they will give you a result between 0 and 1. If the threshold value, let's say this is 0.5 is a threshold value, if you are getting 0.55, you will put in a class 1. If you are getting a value 0.49, obviously you will put in a class 0. Okay, so this machine learning algorithm, once they are trained, they will have certain threshold, and based on that they decide whether a new, let's say new customers, if they are coming, whether they're gonna churn from let's say a telecom systems or not, whether they will take SIM of that company or not, or whether they will churn, right? So this threshold is very important, and that is why we are using this sigmoid function, so that our value will reduce and oscillate between 0 and 1. They will excuse the value will excuse between 0 and 1. Okay, so so this is, as we already told you, this is a classification problem. So the value less than 0.5 you will say 0, and the more than that you will say 1. This is the two class. Okay, and 0.5 is a threshold. So logistic regression, how they predict it, the new, if a new customers are coming, if a new instances are coming, so how they will predict it. So once they will apply logistic regression, obviously they will apply sigmoid functions, and if the y value is coming out, let's say more than 0.5, then they will say it's 1, or it will say 0. Okay, so this is how they classify it. Okay, and there is something called decision boundary. Obviously decision boundary is a threshold. They are talking about the threshold. The value will not go beyond 0, value will not go beyond 1 and also beyond 0. It will be in between 0 and 1. That is a boundary, that is a decision boundary. Okay, here it is saying 0 and 1, it will not go beyond that. Okay, and there is something called a threshold, obviously 0.5, and it may vary sometime because there are some business decisions. If you have to lower the the threshold, some company may want 0.3 as a threshold, or maybe they want 0.45 as a threshold. So threshold may vary depending on the business problems, but it will have in typically we take 0.5 as a threshold. Okay, so in also in modeling, I will take threshold as a 0.5. Okay, the decision boundary, as I already told you, if it is going beyond 0.5, this is a one of the threshold. If the value is more than 0.5, it will fall under one class. If it is less than 0.5, it will fall under 0 class. So it is saying negative class and positive class, and this is just a decision boundary which is separating the two class, negative and positive, based on a threshold 0.5, and this is just a decision boundary. So whenever you apply logistic regression, the first work of logistic regression is to draw the decision boundary. They're gonna draw a decision boundary based on the threshold, okay, given to the systems. Okay, and then they will separate negative and positive class. So the crux of logistic regression is decision boundary, threshold, on obviously the levels of the class. Okay, this just remember it, and the value will not go beyond 0 and 1, and they will use this sigmoid function for the classification purpose. This is just a crux of logistic regression, just remember that. And sigmoid function looks like a S curve. S means the upper tail is not gonna go beyond 1 and the lower tail is not gonna go beyond 0. Okay, so if you see this one, I have just drawn the line. This is decision boundary. Obviously maybe this is a negative class and this is positive class. Okay, if a telecom operators likes to see whether their customer is gonna churn or not, they're gonna take this, if they are applying the logistic regression, so they're gonna draw a decision boundary. And if let's say a new customer comes in, so how they will decide? If a new customer, let's say Y, so where Y value lies, if Y value lies somewhere here, so obviously they are negative customers, means they're gonna churn. If the Y value, Y equal to let's say 5.67, so obviously it will lie here, so that customer is not gonna churn. Okay, so the decision boundary plays an important role in classification problem and also in the prediction of a new customers unseen to the AI systems. Okay, so the cost function, obviously majority of the times in examination you will be asked what is cost function. Cost function is nothing but it's a sigmoid function. This is a sigmoid function. Fx equal to 1 divided by 1 plus e to the power minus x. This function is making a curve like this, a flat, this something like S. So 1 divided by 1 plus e to the power minus x is making the value of y looks like S curve. So this is a sigmoid function and this is called a cost function. So every single machine learning algorithm has a cost function. Okay, so the cost function is important because the cost function is going to decide how much your algorithm their efficiency is and how they are behaving while predicting let's say a new instances. So that is why every single this machine learning algorithm will have a cost function. Even your simple linear regression, multiple linear regression have a cost function. Okay, they are just equations. So logistic regression and the simple linear regression, if you see their differences, so when you draw in a simple linear regression, you will see the value may go beyond 1 and beyond 0. Okay, there is nothing can stop this regression value their output. So whenever you predict it, the output of simple linear or multiple linear regression may go beyond 1 and 0 because they are going to predict the continuous output. Okay, but in logistic regression, the S curve, the sigmoid function, is making every single value of y naught, the output, lies between 0 and 1. Okay, so you will see the straight line versus this S curve. It's like just squeezing the output. Okay, so this is a typical difference. Okay, and I'll show you also the few difference between this simple and multiple as well at the end. Okay, so if you see the data set of this logistic regression, just see on the right side of this here, these are the independent variable. Let's say tenure, age, address, income, this ED, employee, equip, this call card, and wireless. Okay, so this is some, let's say, telecom company, and this is just a features here up to here. Independent variable is nothing, it is called a features, and this churn is called a target. Okay, but here independent and dependent variable is just used so that you can compare it with the simple linear or multiple linear regression. So okay, so but in classification problem we typically called feature and target variable. Okay, so here target variable is churn, or churn can also be called as a class. Sometimes it is also called as a label, so don't get confused. Okay, so this is a typical case of this logistic regression, and this is a binary output, yes and no. The values of target variable is yes or no. So it means we have to model it like a binary classification problem. Okay, just looking at the data set, if I throw you the data set, by looking at the data set you must have an idea whether this is a regression problem or classification problem first, and with what are the target variable and what kind of algorithm you can apply. At least if you are specialized in it, then I think you will be a good machine learning analyst, or you can say the business analyst, or maybe the data scientist, because the looking at the data and reading the data fast is very much important. Okay, and this is self-explanatory, as I already told you, because this is just telling you the boundary, decision boundary, and 0 and 1 case. Okay, the threshold value. So how we are going to model the logistic regression value? Let's say this is simple linear regression, and if you apply the sigmoid function here, okay, this will become a logistic regression case. So the difference is only of the sigmoid function. Once you apply the sigmoid functions in a linear regression case, it will become a logistic regression case, because sigmoid function will make output value lies between 0 and 1. Okay, that's the crux of this this mathematical formulas. Okay, we are just applying these sigmoid functions to make a linear regression case as a logistic regression case. Okay, because this is just a probability, 0 and 1, then only the value, the y value will give you 0 and 1 based on the probability. So you can model it as a logistic regression binary classification problem. Okay, so this is just extension of the previous one. This was a linear model. Once you apply the logistic regression, it has become a S. The straight line has become a S curve. This is just as simple as that. Okay, before it was predicting the continuous output in a blue case, but in this yellow case they are predicting the discrete output. Means discrete means either 0 or 1. Okay, that is a discrete value. So this is just a mathematical case. Just read it out. So when to use logistic regression? So when you gonna apply this logistic regression, that is important. Okay, so if your target data is binary, obviously if your target variable is a binary, okay, 0 and 1, churn, not churn, maybe if somebody wants to go on a leave or not, you gonna provide leave to someone or not, whether you just increment salary of customers or maybe your employee or not. Okay, whether some has a COVID infection or not. So these are the binary case. So if your data set contains the binary output or binary target, just jump on to apply this logistic regression. And if you need probabilistic result, obviously I have shown you that logistic regression apply this probabilistic approach to classify the output. So if your business problem has this probabilistic way of predicting, then you go with this logistic regression, because probabilistic way of applying is also a algorithm called, let's say, KNN. If I recall it, they also use this probabilistic approach. So when you need a linear decision boundary, as I already shown you, logistic regression gives you a linear decision boundary. It's not give you a, something like a, some other zigzag kind of a decision boundary. For example, when I teach you this decision tree random forest, they use the non-linear decision boundary to predict the output, okay, to model the AI systems. So in that case, if your only requirement is to draw the linear decision boundary, the straight line, then you go with this logistic regression. If you need to understand the impact of a feature, let's say you just like to know how impactful your certain features while predicting the churn of a customer from any telecom company. So you just like to know what all are the important features which are deciding a churn of a customer, because ultimate game of any telecom company is they just want to know what are the regions, what are the features that is creating a problem. That is why people are leaving your telecom service. In that case, if you like to know the impact of a features on a target variable, then you go with the logistic regression. So these are the some case, some clue to model a logistic regression, to use this logistic regression. And you will go with this Python programming. So let me show you a case. Let's say this is a case of a default. Okay, I have taken it from some newspaper discussing the default rates are still high, with 33.2% of auto debit transactions falling in July. Okay, but there is a significant improvement from the failure rate in June. Okay, so let's say a company they want to model it that how many customers are defaulting. Okay, so they have this case here, and based on, let's say, this case, we will model it and we will see how you are going to mitigate the defaulters, how you are going to minimize it. Okay, and how our logistic regression is going to help us in this. Okay, so just see this. Where is the so this Jupyter notebook. This Jupyter notebook is open now, and we have this logistic regression. Okay, so this is one example. Let me show you. So if you see this, some libraries, NumPy, PD, and Matplotlib for mathematical plotting. So I'm just running this one. There's some libraries. Okay, this is just a data set where our data are in the form of CSV, and if you just say head, so it's gonna print you the 5 such records from the starting. So if you see the features, what are the features and target? So employee ID, bank balance, annual salary is the 3 features here, and based on these 3 features here, we are deciding whether your customer is gonna default or not. So defaulted is your target variable, your class, your labels. Okay, and here it is showing 00 because there is also one part here. Here it is not captured. Let's say if I am just seeing it at 20, So what they're gonna give us? They're gonna give us some ones or not, still not ones. So there are in ones also, so don't get confused. Okay, so x and y, x is input and y is output, x is a feature and y is a target variable. So employee id, bank balance and annual salary we are taking as a predictor variable. These are the predictor. Okay, and the target is defaulted. It's a class, sometimes you call it a target. Okay, and this is just training and testing. We are just dividing the data set into training and testing set. This one, x train, x test, y train and y test, both input and output. Okay, and we are saying we are taking 20% as a test data, 80% as a training data and 20% as a test data. You can also select a random state 1 2 3 4 5, that doesn't matter, also you can remove here. And this is called feature scaling. If you see the data set, I'm just running it, I'm telling you what is this feature state, this feature scaling. And here if you see, this is called standard scaler. We are pre-processing the data. And why we are using this standard scaler? Because if you see the data set here, bank balance, annual salary, they are in different figures. Okay, so we want these two features to become in a same scale, maybe 0 to 1. Employee ID in 0 to 1, but this bank balance and annual salary is in two different figures. That is why a standard scaler is used to make it into same scale, and we are just fitting it, train and test both. So this is feature scaling. We have run it, I think, and then we are creating a model. So this creating a model means here we are applying logistic regression. We are just applying logistic regression. Okay, the scale on linear model, as logistic regression is linear model because they draw a linear decision boundary to predict the class. So this is a linear model. And the logistic regression, this is a function here because it is a, we are just bounding by this small bracket. So whenever you see this small bracket, it's just a function, and we are modeling it. So that is why we have used this user defined as a model. Okay, now our model is built in. Now we are fitting the model. Fitting means we are providing the training of x and y. We are training our model here. Okay, that is why only the training part is here, because once we train our model, then we are going to predict it. Okay, now if you see the predict case, we are providing this x test here. Okay, now there's something called a confusion matrix. I'll let you know what is this confusion matrix here. Yeah, okay, come here. So come to this confusion matrix. So let's say you had some 2000 data. Out of that 1920 actually they were not defaulters, no defaulters. And you also, your systems, once you developed it, this logistic regression, your model is predicting no. It means there is a no problem. Okay, your model also predicted no, and actually it was no. It means no default. But the problem lies here. Your model actually say they're gonna default. Your model already, your training set has data which says they are not gonna default 51, but your model is saying they are going to default. Okay, this is also a problem. 51 number of customers, and now you just see 61 6 number of customers are actually are not going to default, but they are predicting they are going to default. Problem is not 6, problem is 51. Okay, actually they defaulted but predicted no, means these are the 51 people, they're gonna take your money out of the systems. Okay, so as a you see, as a, let's say, a business leader, how you are going to mitigate this error, right? How you are going to lower the prediction, I mean how you are going to increase the accuracy of your prediction. So if you see the accuracy rate here, it is still 97%. But the problem is also 51 customers, which is just a peanuts for a bigger business. But had it been a lower MSME kind of companies, for them, the 51 customers is also problematic. If they take lakhs or crores of rupees, it will create a problem. Okay, So the as a business consultant, let's say if I given you a task, how you're going to mitigate this, how you're going to increase the prediction, how you're going to reduce this number. This is called a type 1 and type 2 error. Okay, so for that you apply typically this something called a hyperparameter, which I'm not going to teach you here. Hyperparameter, just I'm just giving you just a hint, because hyperparameter is something which is just tuning the the algorithm so that your prediction accuracy is going to increase, and you can also mitigate this type 1 and type 2 error, type 1 and type 2 error. Okay, so that is why we use this hyperparameter. Okay, so coming to now here, coming back to here. So if you see, we have modeled it, we have a data set. Now we have selected the training and testing. Okay, and we have used this standard scaler so that your input features come in the same scale. Then we have trained our logistic regression and we have applied it. So once we have applied it, we have got this confusion matrix. This is called a confusion matrix because we still have certain confusions, the type 1 and type 2 error. Okay, so this is a confusion error, and we have still have a 97% accuracy, means your model is predicting out of 197 correct predictions, but still there is a 3% error, right? If it is a fintech company, 3% is also a headache. Okay, so that is why constant effort for any company is to minimize the error and increase the accuracy. Okay, so some kind of a strategy is applied here. So if you see, if you also for that study, that is called a hyperparameter tuning. Okay, so every single machine learning algorithm has a hyperparameters, and a business analyst or data scientist, their job is to select the you know the required hyperparameter, which they can fine tune it, and they can reduce the type 1 and type 2 error depending on the business requirement. Okay, so this one is type 1 and type 2 error. So how you are going to mitigate it, that could be done through the hyperparameter tuning. Okay, and also you can reduce some features, and also you can mitigate this error. Okay, so classification and regression, if you see, this is simple one, just to make you sure that you understand the concept. Regression means you are predicting the continuous output. Here this is a continuous output, but in classification this is a binary outcome, affordable, not affordable, or expensive. This is a two outcome, that is a binary one. Okay, this is a discrete one. Okay, so this is a classical case of regression and classification. Okay, so this is a regression, this is a classification. This for logistic regression, this will gonna they're gonna draw a straight line here. This is one class, this is another class. Okay, so if you see the two case, regression and classification, both are supervised, both are supervised learning. Regression gonna give you a continuous output, but classification is gonna give you categorical output. Okay, and for just checking the accuracy, we go with this root mean squared, and here we go with the classification, that is your confusion matrix here. Okay, this is just a differences. And the linear and logistic one, just see this they're gonna draw a straight line in linear regression, but in this log regression, logistic regression, you're gonna get a S curve. The value will not go beyond 1 and 0. Okay, logistic regression gonna solve the classification problem. Okay, predict the value probability of the particular levels of the given value of the input variable as curves, and their target variable is discrete, that is a binary one. Okay, so this is the some difference, and make sure because in examination you may be asked that what is linear and logistic regression, because they look similar, because the regression is both, but the logistic part and the linear part makes it different. Okay, so just take care of this and try running the codes. I'm just sharing you. Okay, this is all from my side. Okay, so thank you so much.